Hey guys, welcome back to the channel. I got a pretty exciting announcement to tell you guys, is that Shining 3D have jumped on board to support us, and basically what their partnership with us is to supply us with some pretty cool technology that I want to show you guys. Now, in front of me I got the EINSCAN Rigil Lite, and I've been using this for about a month now, and through my socials like Instagram and that, I've showed you many different ways of using it. I've also showed the data that comes back from that through CAD on Fusion. And I want to talk to you today through two different things. We're going to go through a bit of a review on the actual product itself, and then make a bit of an educational video on showing you how to sort of use this data that we get from the scanner and put that into play on CAD and basically create designs from it. So what we'll do is we'll jump into the review and start breaking it down. So starting off, the Rigil comes in a carry case with everything you sort of need to get started. Basically, we'll break this down on what you sort of get. So straight off the back, we get this really nice unit, and this is the standalone unit itself. So all encapsulated, battery supply, onboard processing. This thing is jam-packed with so many features, and I've been using it for over a month now, and I have found so many ways to use it. My workflow and efficiency is dramatically increased. And the biggest reason being is because I'm not holding cables and laptops everywhere all the time. I'm not looking over my shoulder to see if the scanner's still tracking. There's just so many things that I never thought would be so beneficial to me jumping to something so compact in design. So the unit itself has many different features. Obviously we've got the traditional IR scanning, which is like a full field that you can use for tracking in terms of markers or features. That unit or scanning method is quite good for larger surfaces and everything like that. So let's just say we're doing a feature dense kind of body and we want to get some large scale area. That is perfect for that. Now, if we want to talk about volumetric kind of density and getting really nice mesh scan, we push to like a blue light laser. So this is going to have two methods. We're going to have like a 17 by 17 crosshatch, which is going to be multi-crosshatch between X and Y and pick up a lot of data quickly. Then we've also got a parallel lines. And what parallel lines are going to do is basically get into those crevices that the crosshatch might struggle with. And the cool thing is you can switch between those modes on the fly. Now, if you want to get something like depth inside of an engine block or, you know, threads and stuff, that is where the parallel comes into it. The blue light laser scanning is something that's significantly taken over the scanning industry, and the data that you pull from that is so crisp, it's not funny. Like, I remember years ago, and I've been doing scanning for a long time now, and I've gone through many different methods and all different scanners and stuff like that to eventually get to, you know, something like this, which this is phenomenal in how it works. I'm so impressed, it's not funny. And I've worked with EINSTAR before in terms of their previous scanners that they've had. They had the original EINSTAR, and I've still got that unit and I still use it and my mates still use it. So it's a pretty cool, nifty thing there. And Shining 3D as a whole company are the ones that have the subdivisions off from it. And they've been in the industry for a very long time. They're a mecca when it comes to what they produce in terms of scanners, the grade that you might need them for. We've got dentist kind of stuff. They're a very big company. And the thing I love about that company is that they scale their top of the range stuff down to the consumer grades, which is awesome. They're not a company that only started very low and built up. So their technology is phenomenal in what they've got. And in terms of the blue light laser that we have, I generally scan most of my stuff in a crosshatch assembly, so 17 by 17. The cool thing with this is that it does have blue light laser scanning with no dots, which is, I didn't even know was a thing until I found out that this unit comes packed with that. And I've been using it and it's pretty crazy. So if you've got something that's feature dense, you can push around it with no markers. Now for me, I generally like to use markers because my stuff is quite complex in design and I like to get accuracy right down, because you'll notice that I do a lot of machining, and a lot of the stuff I do these days is actually referenced off all these models with how crisp it is in the volumetric data that we get through the mesh and all the point clouds, I guess you'd say. Now with this unit itself, we can go through and actually process everything on board. So it is a standalone unit in itself that can actually render and optimize all of the data that we have. And if we want to, we can save it as a project and push it onto the computer for EINSCAN to do our final processing on there. Or we can use the settings that are on here, go through it, clean up the mesh, optimize it, and send it as an STL to a computer, or we can even put it into the cloud. So just things like that is crazy. Like I could be scanning, process it, send it to someone, you know, or we can jump on the computer that's in an office and we don't have to bring it out into the field. It's stuff like that, which is, you know, the little things you don't think about. But when you get out there and start scanning, that's what I find is the little 1%ers that really add up and make your workflow very nice. Now, obviously being in a workshop environment like fabrication, we have a lot of stuff like dust, fumes, you know, we got all grinding and stuff going on. The less that we have to have around us, like cables tripping over computers and that, the less we're going to damage and, you know, ruin, I guess. So the unit itself lasts about 2.5 to 3 hours of scanning, and I've tried that. The battery life on this thing lasts so long. Now, the thing I look at this for is remote jobs. I like to go around and do a lot of stuff for people and be able to rock up there with just this and then go home to a nice environment and actually finish the job off. That is such a crucial thing to me, I guess. And I really appreciate the ability to be able to do that with this. Now, we'll jump into, as we start to scan and do some of the educational stuff we're going to do in this video, we'll talk about all the different settings and, you know, I guess how we set this up to scan and how we process it on board. Jumping into what else we get into this, we're obviously going to get some extra batteries, which is nice to have, so we can have a second set sitting there to push out the capacity and what we've got. We've got a nice little cradle. The cradle is just to lay it on and not damage it, I guess, on the front screen that we've got. We come with some markers. We've got a charger assembly cradle. We've got a remover for the dots. We've also got USB to USB-C, so fast transaction speeds through that to the program. 240 volt adapter, which is nice for our region in Australia, and another cable that comes with that to charge it. We also come with a calibration plate. This is very standard in what you need to set up a scanner. Basically, it's going to be a constant thing over a duration of a couple of months. You're going to go through and get prompted with scanner updates and also calibration updates. And what this is going to do is keep that volumetric accuracy, I guess, in check. So you go through, set this up, it's going to do white balance, and it's going to do the marker alignment so that you can make sure that it is calibrated. Now, over the last couple of months, I've scanned a whole range of things like the FJ45 bonnet, I've scanned the mini truck that we've been doing, I've scanned an 8HP for an adapter that we produced. The list goes on with how many things I've been doing. The fuel tank for the Bronco. So many cool things that this has boiled down to being able to do in the workshop standalone without having all the other stuff around us. So what I want to push on to today is that we're going to start working on this FJ45 Dana 60, and that diff is basically been stripped back, we've cleaned it, got it sandblasted, and I put some array of 6mm markers on it. We've also got a swivel hub here, which is a kingpin setup, and what I want to show you is basically how we get this CAD scan and make the mesh a functional item on CAD. So it's a pretty interesting thing these days is a lot of people would reverse engineer this and make like a parametric model to basically use the mesh to create the model. Now, I don't do that much anymore, and I save a lot of my workflow because I make the mesh usable. And because this scans so accurately, there's no real need to use any kind of measuring or verniers or anything like that. Like, I'll tell you right now, if you actually cut these things into shapes and stuff like that to test the accuracy of it, you'd be very surprised at how well this picks up. I generally scan around the 0.5 volumetric kind of input. If we go any lower, you very quickly saturate your data that you probably don't really need, and you'll make it harder to work on the computer. We'll talk about that later on because it's a very big piece to basically making your experience of this efficient and optimized versus trying to get the most detailed thing you think you don't actually need. So what we'll do is we'll go through, scan that diff, we'll get it all in there, and we'll make these hubs actually move on there, even though they're mesh data. So when the unit powers up, we've got two options here we can go between. We've got laser or infrared. We're going to run with laser for this diff scan. And then we've got all of our options on the side here too around how we want to set the scanner up. So we'll go into here, which is advanced settings, and we've got it currently at 0.5 resolution. Now, any lower than that, you start to really get saturated in your data, and you will load your computer up as you process that in point clouds moving around in CAD. In terms of what we require, so because we are using marker alignment, we've got them set up, and this can take an array of different ones. We've got 3, 6, or 12. Also too, you can do global markers, which will basically scan all of your dots prior to scanning the object, and then that will sit in the background as an overlay for that alignment, which is awesome for large scans. We do have a feature alignment too, so if it is dense in features and it's not shiny or super black, we can actually go through and basically scan this with no markers at all. Now, what I'm going to set this all up as is 0.5, high FPS mode, and marker mode. So we'll be using 6mm markers. And then when we go to start scanning, you'll see that the dots start to show up on here. And when it's happy, we'll press play, and I'll ask you to stay steady. And as it starts to capture that data, it will start to let you scan as you move forward. We do have a overlay on the side here of FPS, frames, points, and markers, which is pretty cool to see all that stuff as it accumulates data in here. And then we also do have a mode here where we can go full screen if we want to see more of that, because we might accumulate a big scan over time. And then we do have the brightness setting here, so we can go up and down. Generally, I like to start about halfway or up. And this is going to help with different things like black or shiny stuff. We have outdoor settings here, and we also have switch to reflective mode. So if we are scanning something like aluminium or billet or something like that, that does help too. So at the moment, we're doing a sandblasted Dana diff. So we'll set up about half like that, and basically we're good to go. So this is our Dana 60 assembly that we've got that we stripped down. We've got it all sandblasted, brackets taken off, and you can see it's got this nice bare kind of steel now, which is perfect to do the light scanning on. You can see our laser starting to protrude now, as it can see all of the objects that it wants to start tracking with. So all we'll do is we'll press play, and as we hold it steady now, we can basically go through and start scanning straight across the diff, and you can see how quick I'm moving. The tracking on this works really well, especially with having a couple of dots within range all the time. Now we can opt for different ways of scanning this. Obviously the punctum of this is quite feature dense, so we could scan this in IR or laser no marker. But generally for my application, I just jump straight to all of the dots, and these ones that I've gone on here are magnetic, so they're not sticky. I can just take them straight off and pick them all up and put them in its case. So I've pretty much picked up most of this housing already, and you can see how quick I'm moving through it. So we'll go through, get all of this data, and then we'll jump to the hub, because we've got some pretty interesting way to scan with that. We're going to use 2 sides of the hub, and then we're going to do a marker alignment on the device itself, so that we can scan 2 different sides without having to float the object and try and get around the back side of it. We've gone through and set up the Dana 60 knuckle. Now both sides of these are pretty mirrored in their design. So because this is a kingpin assembly, which is like an old Chevy Dodge setup, they run a steering input on the top of the kingpin, which means most of the knuckles are going to be mirrored both sides. The beauty of that is that we can scan one of these, and in CAD we can actually mirror that mesh to duplicate it instead of doing 2 different scans that we don't need. Now if it did have an independent kind of knuckle support on it for pick up off drag link, we would probably go through and scan them separately to get that Ackerman that we won't need from that. So this assembly that we want here, the reason why I want to scan this is because we're going to model it on those kingpin joints, and then the access through these 2 bearing provisions, we're actually going to mimic that in CAD at around 40-degree steer lock. So the reason for this is to show you how to use that mesh as a functional model versus actually needing to reverse engineer off it. So it really depends what you want to do with a lot of things. This diff that I don't really need to redraw this diff as a solid parametric model. It's not going to provide anything to me unless I was going to manufacture that diff. So let's just say I wanted to create a new casting for the center. Now for me, I only need this diff to basically see tolerances in the FJ, and also to bracketry for our link assembly. So there's no point spending those hours in our workflow and passing it on to a customer when we can actually just make this a simple design and build off the mesh data, which is a pretty cool thing, and a lot of people are starting to use that moving forward. So we're still set up on our scanner, and obviously when we scan that one, that's created a new project file. Because we've just completed it and we're going to scan again, this will now put this in the same project file as that. And that is a crucial thing too. So if we are going to scan something and bring both of these files together, which we're about to do with this one, where we merge two different separate scans into one, what we do need to do and ensure is that it is in the same project file. Otherwise we will struggle to get them to merge to each other. So as we go through now, we've gone and put a various amount of markers on this. Like I said, I get pretty happy with these because they are magnetic, so may as well have more on there than I need. With the sticky ones, I do get a bit more scarce on them and don't put so many. So as we go through, we can now pick this up through the scanner, and you'll notice that on the bottom of this plane, which we'll call the bench, we've already got a mat that we've put markers on. And these are a great tool to have if you do a lot of scanning, especially on like components like this. So it gives us something that we can always keep laying down and quickly scan stuff. And it's not as wasteful on the actual dots themselves. So what I'm going to do is go through, scan the whole top. And generally when you do this kind of dual layer that we are going to merge them together, you want to have a good overlap. And you want about 10% overlap. So let's just say if we cut this model in half, we would want to scan about 60% of that, vice versa, so that when we cut them, or we do actually merge them, we have that overlay for it to pick up. So another cool thing with the Rigil is that we have multiple different ways of how we do all this. So we've got marker alignment, feature alignment. We can manually pick points and actually align that itself too. The one thing I haven't been used to for a long time with marker alignment like this, or sorry, feature alignment, is that the actual marker alignment itself is something that's new to me. So you can go through and pick multiple dots on this, and because you've scanned two different sides of the same dots, if you don't disturb them, we can purely align this in its plain form and bring the merge together just off the actual dots themselves. So we'll go through, scan all this, and then we'll flip it, and I'll show you how we merge this on the device. We can also do that on the actual program itself. It just depends what you want to do. For me, it's actually easier just to workflow this instead of doing it on the computer, because I get a pretty good idea what it's going to look like before I get home and jump on the CAD. So this is one side of the model that we're left with, and you can see that we've got all of our data around there, and I just want to show you how quick this can move around with the onboard processing of it. So we know that computers generally jam up quite easily with this kind of data, and to be able to do this onboard and process it is pretty crazy all in your hand. So what we're going to do now is go through and basically take away the data that we don't need in this, which is going to be the bottom plane, and we're going to take around 10 to 15% off the bottom as we're going to merge those two together. So we're going to help ourselves by getting rid of the floating stuff that we don't need. And I generally just like to line it up semi like that. We'll go over to the chopping here, and then now we can go through and draw our rectangle. The thing I like about this on board here is you can see that your finger would show would hide where it actually is going to finish off the square. But up in the top left here, we've got a nice little window that sort of shows us where that's going to finish and what we're taking away. So it's the little small things that we take for granted on stuff like this, but it helps us so much. So go through, do that. We'll click our rotation again, and we can see there's a bunch of stuff sort of in the field, generally because if we have reflections or anything like that, we will get an accumulation of data. So what I'll do here is we'll just take some more away to help it out. And then once we post-process it, most of this will get taken out as we do the removing floating objects. Go to about there, pull that away. And I reckon there's probably enough taken away there that we can go through now and process this and let the actual optimization get rid of that for us. So we'll complete that, and then we'll pop into this. Now we've got our model, we'll go optimize, and as this sorts through itself, it'll take about 2 minutes generally, and then we'll jump back into the other settings. This is what we're left with after we've done the optimization, and then now we can go onto the other side here, and we can start to go through and generate our mesh file. So we've got kind of smoothness depending on what we're doing. I guess depending how geometrical you want to make the actual object and how, I guess, dense in its design, we can go through and change that to try and smooth it out a bit. remove floating objects and stuff, so we can bring this up a little bit. Generally like to go around 10, and that will get rid of some of the floating stuff that we've got in here. Now, fill markers is a good one. If we've got kind of markers on here, we'll go through and remove them so that we have nice surfaces. And then watertight is basically if you want to have a complete scan that you want to 3D print or something like that, you generally need to have it watertight, which will go through and backfill those designs in. For me, it's something that I don't generally use because I put all this stuff in CAD and do it myself. But if you are sort of a hobbyist or you're scanning stuff that doesn't need to be taken into CAD and you've done a very nice scan, this could finish off that model for you and basically 3D print it. So we'll go through and complete this out now. And depending on the size of the file, it can take between 1 minute to 5 minutes depending on how large and how many triangles that you've actually processed on here. After we've gone through and generated our mesh, this is what we're left through. So obviously we're going to go through now and join them together, but I want to show you quickly just like the detail we get from these scans is crazy. So we're going to go through now and join these projects up. So obviously we went through and cut the model down to get rid of that stuff we didn't need, and we're going to join these together. So we go through and we go complete, and then we're going to go back to our projects. And you can see they're both populated in here, fully done and generated. So now we can go to the puzzle piece over here. I'm going to go through and pick our models that we want. So project 2, project 1. And then now we've got both of these in here. So what I like to do is generally try and align them up a little bit. So we'll zoom in here, get this one here. So this is spun around. And we're probably going to be, that's going to be our studs. So we'll go this way. And that's going to be basically our 2 models that we want to bring together now. So like I said, we've got options. We can do auto align, which is generally pretty good, but once we get complex designs and stuff, it can struggle a little bit depending because it's trying to understand it. Now, if we've got something that's cylindrical, you will struggle starting an alignment with auto because it doesn't understand the difference in features and deviations. But if we do have something that is very feature dense, something like this, it could actually align it pretty well. Or we do have other options where we can go through and do marker alignment. We'll see how it goes with normal alignment. So this was, well, I'd done it first try. So that was auto alignment. And that's bring that together now. And we can go through and confirm that. So we could do it with the markers, which you just go through individually, select multiple markers on each side, which I'll show you how to do that. So you go auto off, come back to this, and now we've got marker alignment. And we can zoom into this, and because we haven't changed these marker positions as we flipped it, we can double tap them. And this is what's going to generate our points for alignment, like so. So we do that on both models. And then we can go through and do that. So instead we're going to go back to the auto because that actually shocked me at how well that brought those together so quickly. And like I said, I always generally like to semi-self align it for it. Bit of a kind gesture, I guess. We'll go align, that's our model. And this is a beauty. The beauty of this is that we don't have to try and move this model around and scan it or do global markers or anything like that or suspend it. We can just do the 2 separate models. So we can confirm this now. Complete. Go back to this. I'm going to generate our mesh now. And this will go through and leave us with our model. So once this processes, we'll be left with our joined model. And obviously we've gone through and done our Dana 60 scan. So what we'll do now is jump on the computer and we'll start showing you how to use all this. So we've gone and jumped on the computer now and we're currently in EINSCAN. So this is Shining 3D's application for the Rigil. And basically this is the final mesh that we've actually gone and post-processed. So we've done a little bit of a watertight situation on this, and we've done the filter just sitting at normal on this, so we don't have to do anything like smoothing or anything like that, because I wanted to show you the raw information that comes back from this. So we've got our foundry ports here and everything, casting abnormalities and the casting features on it. We've also got our number on the side of this too. So very accurate in its design. And now we can go put this into CAD. But I thought I'd just sort of show you the back end of the program once it's sort of been done. We do have the home of where most of my setups are. So these are all previous scans that I've done, and you can see how like very quick application, especially at processing and joining them all together and doing all your final stuff. So it's very powerful in that design. This was a filler neck that I actually done too for one of the race car situations I'm doing at the moment. But we'll jump into Fusion now. So this is the FJ45 build that we're doing. It's very full on in design. It's a compound 6BT with triples and coilovers all around. We'll be housing a 14 bolt rear diff and a Dana 60 front diff. Now, for this particular build, I've opted to go and flip it. So it is a Kingpin Chevy drop diff. Yes, Ford does come the opposite side, but we've opted to stay for this diff because of the packaging lengths and everything like that. And also being a Kingpin assembly. The ball joints, we can do upgraded kits and that, but technically we can't do any welding on knuckles in Australia. So to put those kits into it, it's technically not correct on how you would put them in, and it wouldn't line up with engineering correctly either. So what we're going to do is flip this and put it at the drop that we need, and we can also, clock all of the stuff too. So the steering that we have in this, say generally about a 3 to 4 degree of caster in this, we want to push that. So due to the suspension and the cycling on this, we actually want to put probably about 6 to 8 degrees of caster. So we'll get a bit more better steering characteristics. The car will hunt for zero as we start the drive, and also through its range of motion in suspension travel, will always stay in a good positive caster situation versus having it invert and steer under itself. So bit of food for thought there. Now, in terms of our differential, this is our Dana 60 that we scanned today. And I thought I'd show you just in the detail that we've got of how well this has come in. I was flying through this scan too, because like I said, we don't need to have every little bit of detail because we're not reverse engineering this. All we're doing is making brackets off the tube. So what I've done is I've already gone through and done the alignment on this and got it positioned correctly in space, I guess, or into its actual XYZ. And I've gone through and split the bodies through the facing so that we can actually move this center housing to the right-hand side and change and flip our Cs. So now that we've done this one, I'm going to show you how we actually go through and start a new, I guess, mesh insert and project alignment, I guess. So I always like to start with hybrid design. It's a new feature that Fusion's sort of gone through and made now. And what we'll do is we'll go up to the mesh top section up here, so this header, and we'll go through and insert mesh. Now, the reason why I insert mesh is because it scales it correctly as per the scan you've done. So we've got our project here as Dana 60 knuckle. We'll pick that. I've outputted the file as an STL. You can do it as object file too. So this is obviously going to have all its 3D data within it too, so it's actually referenced to stuff. Once we load that in, that's our knuckle. Now, the alignment is not really going to be too crash hot once it comes into Fusion. It's one of those things where you got to do a lot of manual work to sort of get this happy. I generally put it somewhat of a reasonable starting position. But what we'll do now is, once we've placed this, you'll see up the top here, we've got an unsaved project, and it's basically an overall body. So what we're going to do is we're going to go to bodies now. And what we like to do is start with a fresh component. So we'll convert this body to a component. And then now we have our actual substructure of this, and we can start to flow from this. And it's super important when doing this alignment, because if you don't have it selected, all of your sketches, orientations, constructions, all that kind of stuff won't reference to what you're actually working on. So that's a very big factor to it. Now, one thing some people might know with knuckles is that they generally have a thing called KPI, which is kingpin inclination. So a knuckle itself is not actually going to be sort of flat on its face like this. You'll notice that there's an angle here. That angle could be like 7 to 10 degrees, and that's just how steering characteristics on that KPI work. And that's something you need to factor in this. So don't think that this is going to be a straight face towards your actual alignment here of your PCD on your flange. So now that we've gone and made our subcomponent here and it's individualized, what we're going to do is activate it. So on the right-hand side here, we activate it. And now everything we do is referenced to this and encapsulated within that data file or in that folder of the knuckle. So now we're going to go to the mesh and we're going to go to direct edit. So this lets us actually edit the mesh itself. Normally you wouldn't be able to do it because of the constraints and stuff in the background, not letting you pick any facets, which are all the tiny little
triangles on here. So now that we've done that, what we can do is start to reference geometry. Now, as you will see, this paint brush has come up. If you do have a computer that is not specced out a lot, this will actually really slow it down as it tries to paint and do stuff. What I like to do is go over here to our mesh section palette, and we'll go window. So now it's not going to do anything unless I input it. It's just a little quirky thing I do to stop it loading up the computer so much. Once we've done that, what we start doing is referencing. So we'll go into our 3-point of plane. So this is going to let us create a construction plane on this and give us reference data. So the plane through 3 points is a very good one for mesh. And you'll see as we start to lay it down, the cross section that it goes onto the actual mesh. So majority of the time, especially on casting and stuff, you're not going to get a completely dead flat face, and you can see how we have a little bit of extrusion, I guess, coming through of the mesh data. Now that is like 0.1 or point, like it's probably something so small that it's not really a factor. And because we've done 3 points, it's over an average, I guess you'd say. So once we've done that, we'll go through and just reference a whole bunch. So I like to use spacebar. It's a good tool to just keep laying down the same command that you did previously. So I'll press space. Actually, sorry, I have to do that again. And we'll go here. So what's going on here? Oh, sorry, I got out of direct edit. So unless you're in direct edit, you can't keep applying the faces. So I thought we were finished there and clicked out of it. We'll jump back onto that, and then now we can keep putting our planes in. It's a lot to sort of remember when you're doing this because there's a series of events you do which dictate it through the whole build. If you stuff up one thing, it really can throw out the alignment of all this. So we've got that one there, space again. We'll pick up this face. And like I said, it will average through those 3 dots that you lay down. What else do we want? We probably want to go bottom side face. I also do have my quality settings down the bottom here set on high, so you'll see that there's a lot of shading and everything like that. I just like it because it's visually appealing and the computer can handle it, but by all means, if you have a computer that struggles, I would turn most of the settings down so that you don't load it up too much. So we got some there. We might take another one off the tie rod. Now the bottom side of this is probably not the best because it's a bit inverted, but we can still take some information on the high spots, I guess, just in case. Where are we there? Not too bad. Probably enough to do something. And what else have we got? That's sort of majority of the ones that we've got. Inside's going to have roundness to the casting, so it's not fantastic. So now we've done that, what we're going to do is finish that off, and now we've got all of our construction planes. So you'll see that under our Dana 60 knuckle here, that's activated at the moment, those constructions now follow this. So I've got it currently ground to plane, and we'll talk a bit more on that later on, but at the moment we'll get back to our constructions. And now we're going to use sketch analysis on these planes to give us like geometry and alignment so that we can start to make stuff. So up here we've got create mesh section sketch, pretty big tongue twister. What we'll do is we'll select the body, and then now we'll go select our plane, and you'll see why we made these construction planes, because now when we select them, it will land down where we want to start pulling data from. So just remember, whatever you do in planes, if we have to pull this back to 1 mil or something like that, it's going to offset your face. So take that in consideration when you're doing stuff. So I like to maybe just try 1 mil for now. And you can see it gives us all this lines have gone away because we're now deeper into the mesh. So let's go back to maybe 0.1 and work from that. So 0.1 is still pretty good. And 0.2 cleans up a bit nicer. So I'm going to stick with 0.2. And with the mesh kind of stuff, it can really get slow processing this versus just doing more normal parametric models that you've designed in CAD like 3D. When you start doing the sketch stuff, it doesn't matter how good your computer is. Like this is a 24 gig graphics card with 64 gig of RAM and a massive CPU. It still loads it up. So there's only so many things you can do. We'll go back into that body again. So it's a bit of a rinse and repeat as we start to go through this, but it does help in the long run. So we'll go 0.1 again, 0.2, 0.3. So 0.1's pretty good, what we got there. I'm happy with that. And then the bottom section of this, same thing, spacebar, body, section plane, and we'll go 0.1. So that's going the opposite way. So we'll go minus 0.1. And that's going to do that for us. 0.2. So see these circles, I want to clean them up a bit. They're a bit elongated here. So we might go down to 0.5. That's going to clean it up a lot. Righto, that's pretty good. 0.5, there we go. We will take our steering pickup, I guess, just because we've already started going down this route. We'll go that, pull up our plane here, and then we'll just go down same thing. 0.1, 0.2. Now the cool thing about when we do the actual sketch on this now, it will fit curves to sketch that we use, and basically it can average bad data to get a perfect circle for you, if you want to say that. But we'll go through now, take our constructions off, and you can see how we're left with sort of this design of all of the sketch data. So we can take our body away and we're left with that data too. So a lot of things you can do with this, and most of my designs are off the back side of this too. So now we'll go into our sketches, and our first sketch that we've done, we'll go and edit it. And what we want to use is a tool up here under the create. We go fit curves to mesh section, and then we've got circle. So this is what I was saying. If we click that, it's going to average all of that data into a nice circle. Now the outside's a bit different. So we'll click OK there. Go back into it, and then we'll go close spline. Now, if you've scanned something really well, a closed spline will complete itself like so. Yep, so now we've got our data there. Where are we? So we'll finish that off and make sure. So yeah, see how we've got that there now. And that's like something we can actually make into a extrusion. So if we wanted to, we went down like 0.2 there. So we could push this out as a joined body, and we can bring our body back in now. Select that, and we can go minus 0.2. Maybe went a bit deeper than that. Where is it? There we go. So it must have been a 0.5 maybe. Minus 0.5. Minus 0.5. Okay. And then now, like, this is sort of getting into the reverse engineering side of things, but it's nice to have a face that I can sort of reference and show you guys what you can achieve by that. So the top and bottom is where we want to create an axis, and we also want to tube it so that we can create a rotational fit or revolt, I think it is, in the alignment joint that we want to do. So when we go to put it onto the side of the C on the axle. So now we'll find our other scan on the bottom here. And like I said, it's basically rinse and repeat through getting all of this stuff. But the more you keep doing it and be systematic, you'll learn how to do it pretty effectively. So see how that there has a bad section on that. If we click this, find a nice spot, it will average that out, which is pretty crazy. So now we've gone and done that. What I like to do is we can see that that's done that top scan there. I reckon if we look at this, we'll put a bit of a infill in it maybe. So let's pull a circle on it, and that takes us out to about 57 mil. And I'm going to say, we're not doing this for engineering in terms of tolerances and that, so we're just going to call it something like a 53. We'll do that. And then you can see as we go. So if we made a plane on the other side here, what we can do is actually pull that from one side to the other and be pretty bang on with that tolerance. So you can see I've just pulled that through. And the reason being is I want to have a nice solid piece in there that we can actually align to. So at the moment, we'll just go 34 mil. I'm going to go join, push that into there. Like so. And then same as the bottom. So once we do this, now we can go after that and start creating alignment tools, I guess. So I like to use sketches to align. And it's pretty much the only way unless you do that or visually or use another application. So we're going to go back into that bottom sketch that we want here now, which is going to be that one. Same thing, back to the circles. We'll go fit mesh section. Zoom in on our circles here, average that out. Now we made the other one, I think it was 34 mil. By maybe 34 mil from memory. Chucking in here, what was that, 34? Nah, so this is going to be different because the top one is actually a different ball joint setup, so, or kingpin setup, sorry. So what we'll do is we'll make a different circle for that. So that goes to 38 mil. So let's call it, let's just fill it up and go 44 mil. This is only really for demonstration purposes, just to sort of give you guys an idea on how to do this. Otherwise, I'd sit here with some verniers and actually check the bearing or the tie rod and engagement there, I guess, or the ball joint, or whatever you want to call it. So now we've gone through and made most of our cups. We've got a face there, which is pretty handy for us. So now what we can do is we're going to go up to construction, and I reckon we could probably shoot for maybe an access through 2 cylinders. So we're going to go, let's try this cylinder and that cylinder. I'll put construction back on. Go in here and turn off our other planes. It's through the cylinder, so wonder if we can through 2 planes, through 2 points, through 2 edges. See if we can do edges here. No, it's not going to let us. So we'll go through the cylinder like so, and then now that's created an axis straight down the guts of it. This is a bit of a harder model to sort of show you guys versus the diff. That's why I thought I'd take a stab at trying to make this work, because there's so much angle in this to try and straighten. So what I'm thinking is I'm going to go on to this face now, and we are going to create a sketch. And mind you, we're still all active in what we're doing, so that model's the only one being touched, not the overall. And what I'm going to do is I'm going to press P, which is going to be project. And project is going to let us grab that axis now and bring that forward. So what that's going to do is let us draw a line down, like so. And you can see how that's given us a straight face here now. And it's perpendicular to that actual flange. So what we're going to do there now is we're going to create a plane at angle. And because we've given it a known angle now at a face of 90 degrees when we click this. Oh, no, hasn't. Did not like that actually. So I actually hit a bit of a dilemma there in terms of the angle off that face there. So what I ended up doing was creating another axis through the middle of this. Off the internal of this circle, and then once I'd done that, I actually created dots along the axis, so you can see on the ends of this, and then on our KPI line that we've got at the top here was another point of interest. So by doing that, it's created another construction plane like that. Obviously it's not aligned correctly, but that gives us a direct cut through the center of the hub. So it's symmetrically even between the top and bottom. And then from that, I've actually projected those lines again to create these multiple directions here of X and Y, so that we can now align this. And this is the portion where we're up to. So it's a bit of a hard one with this stuff. Obviously, if it's a very easy geometrical shape, we can align it quite easy. But because this is like, I guess we got a flat face here, and then we've got a bearing assembly that's on an angle, it gets a bit complex to try and align and find center points. But we got there in the end. So what my plan is now is to align this. So what we're going to do is align. We're going to go back to activate everything. So now that's overall, and we're going to go to the origin that we've got sitting over here. So that's actually our origin of where we want this knuckle to be placed. So when we place it into other projects, or if we work on it, everything will be aligned. So top is sitting there currently. So what I'm thinking is that we'll do a couple of alignments here. So we've got the face of that, which we can put down. So let's go an alignment on that one down to that one. Oh, sorry. So this is that part I was talking about that we have to be mindful of. So the Dana 60 knuckle is still grounded to parent. So what that means is you can't move it. At the moment, I can move it now. If we go Z, Control Z, and go back to that being grounded, click it, I can't move it. So that was that part that I said I'd talk about later. So unground from that, and then now we're free to do what we want. So I'm going to drag that down. But you notice how everything we've done in terms of our sketches and all that follow that, because we activated that part and actually drew on that and done all the assembly. So it's a very powerful thing to activate on that. A lot of people just start drawing and creating bodies and components without having actual structure to the side of this, and it will bite you. So now let's try and align it. So we can do a constraint alignment. I want to show you the easy way of just the alignment. If you want to get technical, the constraint one is better. So let's pick a plane, and we'll go down to this one here, which is now going to align that front plane like so. Our top section of this is going to be flipped, isn't it? So let's see if this will work. We'll flip it. Okay, so that's Z. All right. So that should be all good there now. Go capture position. And then now what we're going to try and do is align off one of these lines. And we'll go to the Z axis because it's our vertical, which is done very well there. And then now let's bring it down to the same level as the X and Y. So go space again, and we're going to click our line that we've got here. And we're going to click our line down here on our origin. Then now that has completely dead centered our assembly. So a little bit of work, but previously a lot of people would start using mesh, and the biggest drama they'd have is that it had no reference to anything. So you can see now, if we put that on an angle, take away that, doesn't matter however we move this now, whatever we do, if we go back to left or right, everything is nice and straight. So when we go to put it into our next model now, we'll be able to align this up, especially with that sketch data we have. So what I'm going to do is probably save this now. I was thinking about mirroring it, and this is what I was going to say to you guys about, I guess, creating that mirror line so that we can create multiple models. So if we wanted to, we could go to mirror. Obviously, we'd like to have an offset plane, so let's quickly do that. We'll go offset plane, and I'm only showing you this because once you see our model that we're working on, which is a diff, you'll be like, okay, where do we get the next one from? So let's do that. We'll go modify and go mirror. We'll go components. Click that component and we'll go mirror line. Okay. This will take a bit to process, and then now you can see we've just made 2 knuckles. So there's no point redrawing and doing all this when we've just made 2 complete setups like that, and that's exactly how a Dana diff would be. Happy days. So looking at this now, actually, we are sitting in a reverse section, sorry. So the alignment of what I'd done is the opposite with the flip there. So that's our inclination. So you always will have the top lead in and the bottom lead out for its geometry. So when we put it in, we're just going to have to flip it around, but sort of get the gist of how we do it all, I guess. And then what we'll do is go back and get rid of the knuckle that we just mirrored. We don't really need that right now. And we'll clean up that plane that we've got. So we'll just keep it back to here. We could actually try and let's go back to a line. Let's go back to our sketch. Let's go that one to that one. Let's see if we can flip that. Okay, so we have flipped it. May as well do it properly. And then we'll bring that back in to our Z axis. There we go. We fixed it. It's killing me that we did it wrong. All right. And now we'll save it and we'll chuck it into our other model. So that'll be a Dana 60 Chevy knuckle. Sorry, I got the microphone in front of my bloody hands. Actually, let's change this to, nah, we'll go Chevy. Oops. Sweet. So once that saves, then we'll jump back into our axle, which is this one. And on our side here, we'll have our knuckle that starts to load into our folder. So this is FJ45 80 series build that we're doing. And once that finishes, we'll be able to align it in here and start to form this up with our knuckle. So the one thing I wanted to do was to show you basically creating a mesh that's usable in steering and stuff like that as componentry, sort of like upper control arms, lower control arms, bush relations and stuff, without actually redrawing it. So while we wait, we are actually going to have to quickly make a joint on this. So the knuckle that we done will have to attach to this. So how are we going there? We've got a bit of data we can pull from that edge, I guess. Righto. So let's jump into this. Now we're already activated because this is our overall. Where we got? That's our whole one there. Okay. So what we'll do is we'll jump back into mesh, direct edit, chuck onto this quickly. Then we're going to go to 3 points. Let's see if we can get one. It's not the best spot, but we'll try. How's that looking? That's not horrible. Okay, so we can run with that. So now what we'll do is we'll finish that and we'll create our sketch analysis. And I just want to do this to get a circle that we can actually reference off this. So you can see how clean that is there. And we've gone up 14 mil. So what we'll do is we'll now jump into that sketch quickly. Like so. Same as last time. And we'll just make the inside 30 mil so that we can get a bit of a cylinder going here. Then what we'll do is we will extrude that. Click that. I'm going to go join to that body. And as we come out, we'll bring it down to 14 mil, like we said. And then you'll notice on the edge of this, we can actually taper it out. Wants to work for me. There we go. So I'm not going to get the profile exact, but just so we can sort of get a bit of an idea. All right. Now we'll hide that, hide that. So you can see we've got a bit of a section here that we can actually work off now for when we import this. So let's go back to overall, and that's our div back here now. So now with our knuckle, what we're going to do is insert it into the design. And you can see when we insert it now, it's actually within reference to an origin, which is awesome because it's so much easier to play around with this now. 90. Okay, let's see what this looks like from the front here. If we've done this right. And then we have to flip that, sorry, I'm the wrong way. 180 degrees. Getcha. There you go. Okay, so basically that's sort of where we're sitting now, and we're going to do a joint onto this so that we can make a hub actually move. So now we're going to press J, and we're going to go into the motion. We're going to go into revolt. And what are we going to do here? We're going to go position. Now, if we did top and bottom of this, we could actually float this between two different faces, but because we're only doing one just to show you right now, we'll jump into that so it's a bit easier. Okay, so one thing that happened just there is that we actually moved the Dana 60, and the reason being is because we haven't released the knuckle. So let's ground this to parent. Sometimes when you do these commands, it throws things out. So let's go back on that. And we'll jump back on the knuckle. Let's break link. We'll go back to J, and hopefully this doesn't segregate the components. It can get a bit sloppy sometimes. Actually, I want to anchor that again. Go J. I think it's because my reference that I did was the reverse of going from the auxiliary part to the main part. There we go. Okay, let's go top viewed. So as you see here, we've obviously got the steering knuckle to the back here because we flipped it when we put it in. Because I'm just sort of showing you what this looks like. We don't really need to go crazy technical and get on the other side. You can understand that this would go that side and the mirror section would go on the other side. So we have our link at the front here for our tie rod. For the demonstration bar, what we'll do is we'll just chuck this on now. Which gets us that. And now, because we've done that, where's our joint? Animate joint. Oh. So I did it as rigid. We don't want that, we want access, sorry. And then we can do minimum and maximum steering angle. So we go, say, 40 degrees, which is going to be that way. And then we got, let's just say 40 degrees the other way. Go minus, sorry. It's going to be that way. And then now we can show you what that does. It's pretty cool. So now we can jump back into our relations, joints, and we can go through here and actually animate that joint now. So you can see it will keep moving through that area. So it's purely just a representation of showing you that mesh can be used and you don't have to spend all the time reverse engineering just to be a 3D model. So basically now what I'll do is I would go through and create these knuckles both side. I'll go through and flip this housing. So I'll put the center casting into the forward position and we'll retube this actual axle. But now what I can do is pretty well get this underneath that FJ build and show you what it actually looks like later on down the build. So after all that, pretty long video, but it's very hard to sort of show that off in a live kind of presentation versus having it sort of all set out and done to show you. But you'll take a lot from that if you follow back through all the steps we've done. And I'll see you in the next video.